Now let's recall the concepts of completing the square and using the quadratic formula to solve standard quadratic equations. Consider the following example.
Alright, let's consider this problem. Let's look at x squared minus 4x plus 4 is equal to, let's make it equal to 12, for example. Alright? Okay, now let's look at this trinomial here on the left-hand side. Alright? Is this a perfect square? And the answer is yes, it is. The first term is a perfect square, so is the last term, and the middle term is going to check out as well. Let me show you why. So A is my what? A is my x here, because a squared is x squared, right? B is what? B is 2, because b squared is 4, so b is 2, alright? Let's check a times b. X times 2 is what? 2x. Double it, what do you get? 4x, and that's what I have here in the middle term. So therefore, this x squared minus 4x plus 4 is a perfect square. And you remember the formula is a little different from the last example. This will factor to not a plus b quantity square, but what? A minus b quantity square. So it's going to be x minus 2. Because the middle term is what? Negative, right? X minus 2 quantity squared. Alright, equal to 12. Alright, can we see that? So again, let's take the square root of both sides then, to finish this off like the previous section. So x minus 2 is equal to what? Again, square root and square cancel each other off essentially, right? So I get x minus 2 equal to what? Plus or minus. Now the 12 is what? 4 times 3. So what can I take out? I can take a 2 out, couldn't I? So plus or minus 2 radical 3. Hopefully we can see that without too much trouble there. Alright? Then I'm going to add 2 to both sides to finish this problem off. So therefore x is equal to what? 2 plus or minus 2 radical 3. Are you with me on that? Alright? Let's do one more here. So again, if this left-hand side is a perfect square, I can factor it that way and then apply the same technique I used in the last section to finish solving it. Make sure we see that. Let's look at this problem. Let's look at x squared, excuse me, x squared plus, let's make it x squared plus 12x plus 36 is equal to 7, for example. Alright? Again, is this trinomial here on the left-hand side a perfect square? And the answer is, in this case, yes it is. A is equal to x. B is equal to what? 6 in this case. Again, make sure we see how I got A and B here, right? Because B squared is 36, B must be 6. Then multiply A and B together. Again, I need to check if this is a perfect square or not. If this will factor into a perfect square. I'm just showing you the work right now. So that's 6x. If I double it, I get what? 12x. And that's what I have in the middle term. So therefore, this will factor to A plus B quantity squared. So it's going to be x plus 6 quantity squared. Can we see that? A plus B. Alright? So that's equal to what? 7. Again, that didn't change. My point is what? Recognize that the left-hand side is a perfect square here. Likewise up here. Okay? Now I can do what? Apply the technique from the previous section by what? Since I have a perfect square on one side, number on the other side, I can take the square root of both sides to finish solving this. So I get x plus 6 is equal to plus or minus. Again, every time I take the square root, I get what? Plus or minus. Right? Remember that? Square root of 7. Here I'm going to subtract 6 on both sides of the equation here. Sorry, I ran a little bit off the screen there. Alright, that's 6 right there. So I get x is equal to what? Negative 6, right? Plus or minus radical 7. Square root of 7. As our solution here. Alright, can we see that? Now, you may wonder, okay, well look, that's great. But what if the left-hand side is not a perfect square? So let's look at that situation here. Alright? And that's where completing the square comes into play. Alright, so let me go and clear out this. Let's look at the material from this section here, right? Suppose I give you a problem like this. What if I have something like x squared, let's say, plus 10x, x squared plus 10x plus, let's make it plus 2, is equal to, let's make it equal to 5, for example. Alright? So in this case, look at x squared plus 10x plus 2. That is not a perfect square. Can we see that? Alright, that is not a perfect square. So the technique I'm going to use in this section then will be what's called completing the square. So let's look at that technique in detail here. Right? The first thing we're going to do when we complete the square is we're going to get this constant term on the other side. So step 1, you want to get constant term. get constant term on left side. Oops, sorry, right side, my other left. Sorry about that. On the right side, alright? So what that means is what? We're going to subtract 2 from both sides of this equation here. Okay? So then I end up with what? I end up with x squared plus 10x equal to what? 3. Are you with me on that so far? So again, move the constant term from the left to the right side. You can get constant term on what? Right side. Sorry about that. Okay. So what happens next? Well, we're going to figure out a number to add to both sides. All right. Let's figure out what that number is, and that number is going to be related to this 10 right here. It's going to be related to the x coefficient. All right. Here's what we do. Okay. Here's the number to add to both sides. Number to add to both sides. Okay. Now, why am I adding a number to both sides? Well, I want to add a number to both sides so that the left-hand side becomes a perfect square. That's the reason for that. All right. If I can say x squared plus 10x plus some other perfect square to be some other perfect square, then the left-hand side becomes a perfect square. You'll see it in a moment here when I show it to you. All right. Number to add to both sides. All right. What is that? Well, first thing you do is you're going to what? You're going to take half of that x coefficient. So take 1/2 of the x coefficient. In this case, I'm going to take 1/2 of 10, 1/2 of positive 10. So here I'm taking 1/2 of positive 10. That means what? 1/2 of number means 1/2 times that number, right? So half of 10 is what? 5. Well, you can probably figure it out in your head, right? Couldn't you? All right. And then what do? Well, after we take half of that coefficient, we're going to square it. So square that result. All right? That means what? We're going to square this 5. So 5 squared is going to be what? 25. All right? And that's the number we're going to add to both sides. So add that number to both sides of the equation. Okay, so again, let's backtrack. So first, let's figure out a number to add to both sides. So first, I'm going to get the constant term on the other side, on the right side, by subtracting 2. All right, so we're good on that. I get this equation right here. All right. Then I'm going to look at this x coefficient, which is 10 in this case. Just 10 is what we're considering here. All right. I'm going to take half of that coefficient, which is 5. Half of 10 is 5, right? And then I'm going to square that 5 to get 25, and that 25 is the number, that perfect square is the number I'm going to add to both sides of the equation. Add that number to both sides of the equation. So this equation becomes what? Becomes x squared plus 10x plus 25. So I'm adding 25 to the left-hand side. But again, I have to add it to both sides, otherwise I'm changing the problem. So I must add the same number to both sides. Keep that in mind, otherwise you're changing the problem. You need to keep the equation balanced. You must add it the same number to both sides. So x squared plus 10x plus 25 equal to 3 plus 25. Can we see that's already squeezed that plus 25 on the edge here, alright? So I'm not changing it, I'm just adding the same number to both sides, alright? But look, x squared plus 10x plus 20, that's a perfect square. First term is a perfect square. Last term is a perfect square, the 25 mainly. And the factoring of that is going to be x plus 5 quantity squared. So you can figure that out without too much trouble. That's equal to 3 plus 25 is what? 28. Can we see that? So after I add this magical 25 to both sides, you want to think of it that way, I'm going to get a perfect square on the left-hand side, and which means I can factor it that way, which means I'm now back to a problem from the previous section, which I could just finish solving it by taking the square root of both sides. Can we see that? So then I'm going to get x plus 5 equal to what? Plus or minus 28 is 4 times 7. What comes out? 2 comes out, right? 2 radical 7, right? And then subtract 5 on both sides of the equation to finish this. So x is equal to what? Negative 5 plus or minus 2 radical 7. Sorry to squeeze this answer in on you here. All right, there's our solution. X equal to negative 5 plus or minus 2 radical 7 for this problem, which I could not factor as a perfect square initially, right? But then I somehow found a number to add to both sides to make it into a perfect square, and then we finish solving the problem. But again, how do I get this number? We take half of the x coefficient, half of 10 is 5, then we square it, and then we're going to add that number to both sides to turn it into a perfect square on the left-hand side. All right, can we see that? Okay, let's look at another one here. All right, let's look at another example here. Let me clear out the screen. Let's try this one. Let's look at x squared plus 16 plus 16x plus 16x minus 1 is equal to, let's make it equal to let's make it equal to 11, for example. All right. So again, left-hand side is what? Not a perfect square at the moment. Okay. So what I do first then? Well, I'm going to get this constant term to the right side. I'm going to add 1 to both sides. Okay. So can we see that? So I get x squared plus 16x equal to what? 12. All right. 16 there. Sorry about that. Okay. So again, what I do with the 16? I'm going to take half of it. So I'm going to take half of that coefficient, half of 16, half of positive 16. That's equal to what? 8, right? Okay, so that's 8. Okay, so then what I do with the 8? I'm going to square that. Square the 8, 64. Can we see that? 8 squared, 64. So the number I need to add to both sides is what? 64. Hopefully we can see that without too much trouble. Okay, so let's do that then. So this equation becomes what? X squared plus 16x. All right, plus what? 64 equal to 12 plus 64. Again, you got to add the same number to what? To both sides of the equation. Otherwise, you're changing the problem. All right. Okay, then. So that's a perfect square now on the left side. What does that factor to? Well, again, that's the factor to x plus 8 quantity squared. Now, you may also wonder, well, aside from knowing the factoring formulas, my a is x, my b is 8. Well, that's why this factoring is a plus b quantity squared. But aside from knowing that, look at the number 8 here in the factoring. And look at the number 8 after I took half of 16. Can we see that? It's the same number, basically, right? So my point is this. The number that goes in the factoring of this perfect square, trinomial right here, is the same number where we took half of the x coefficient. In other words, this number here, it has to go into the factoring. Okay? Again, this number here is always half of this number, is what I'm trying to say. Okay? So the number that goes in the factoring is always half of the x coefficient. Keep that in mind, all right? So the coefficient is 16. The factoring is going to be what? 8 right here. X plus 8 quantity squared. And that's equal to what? 12 plus 64 is what? 76. All right? Just punch out the calculator or do it in your head. All right. Now I'm back to a problem from the previous homework. All right? Now I can take the square root of both sides then. So I get x plus 8 equal to plus or minus. Let's look at 76er. That's 4 times 19, is it not? All right. Just take your time on that. 76, 4 times 19. All right. So what comes out? 2 comes out. All right. So plus or minus what? 2 radical 19. All right. Let's finish it off. Minus 8 on both sides. Takes care of that. So x is equal to what? Negative 8 plus or minus 2 radical 19 as our solution here. Okay, so again, keep this in mind now. The number that goes into the factoring of the perfect square is always going to be what? Half of the x coefficient. All right, let's keep that in mind now. Let's try another one. Let me go and clear out the screen. All right, let's go and try this one. Let's look at x squared minus 6x is equal to let's make it equal to 4. All right, if you don't mind. Okay, then, again, this equation, this is a quadratic equation that cannot be solved by factoring again. So let me figure out, now, there's no constant term here, right? So I can begin figuring out the number to add to both sides. So let's go and do that. So let's take half of the x coefficient. And what is it in this case? Half of what? Well, x coefficient is what? Negative 6. Can we see that? Negative 6. Half of negative 6 is what? Negative 3. Can we see that? 2 and a 6 3 times, all right? Negative 3. What do I do with this negative 3? Well, I'm going to square it. Negative 3 squared is what? Positive 9. Can we see that? So I'm going to add the 9 to both sides of this equation. So this equation becomes x squared minus 6x plus what? 9. This number I'm going to add to both sides. 4 plus what? 9. Again, add the same number to both sides. Alright? But again, once I add that perfect square 9 to both sides, it's now a perfect square, this entire trinomial that is. So I can factor it. Again, what number goes into the factoring? Well, again, what's half of negative 6? Well, we figured out earlier, half of negative 6 is what? Negative 3. So x minus 3 quantity squared. Can we see that again? The number that goes into the factoring of this trinomial, of this perfect square trinomial, is going to be what? Half of this x coefficient. So x minus 3 quantity squared. And notice that negative 3 is what? Half of negative 6. Alright? Equal to what? 13, 4 plus 9. Okay. Alright, well, are we good on that? Okay, let's go ahead and take the square root of both sides. And once I get that situation, so I get x minus 3 is equal to plus or minus what? I can't simplify that. Radical 13, square root of 13. Add 3 to both sides, and then we have our solution. So x is equal to 3 plus or minus what? Square root of 13 as our solution here. Okay, hopefully we can see that without too much trouble here. Alright? Now, let's go ahead and look at a case where this x coefficient is an odd number, right? It's an even number, it works out very nicely, as you can see. What if it's an odd number? Let's try this one. The concept's still the same, except we're going to deal with some fractions here. Let's try this one. Let's look at x squared, x squared plus x squared plus x, let's say equal to, let's make it equal to 3, for example. Alright, equal to 3. Okay then. Now, let's figure out the number to add to both sides again. There's no constant term to move to the other side, so I'm good on that. But let's take half of the odd coefficient for x now. Take half, what's the coefficient for x in fact? Invisible what? Invisible 1. Half of 1. 1 half times 1 is what? 1 half, right? Let's square that. Again, you need to take half of that number and then what? Square it, right? So half of 1 in this case, half of the x coefficient, and then what? Square it, square the 1 half. What's 1 half squared? Isn't that 1/4? Yes, it is. 1 squared is 1, 2 squared is 4. Alright, are we good on that? So we're going to add 1/4 this time to both sides of this equation. Alright, so we're going to get x squared plus x plus 1/4 equal to 3 plus 1/4. Alright, make sure we're okay on that. Okay then, let's go ahead and look at the factoring of this trinomial. It's now a perfect square. Again, once you add the 1/4, in this case, you're guaranteed to have a perfect square here on the left-hand side. What's the factoring going to be? It's going to be x plus, well, remember what number goes in the factoring? Well, again, it's always what? Half of the x coefficient. What's half of 1? 1 half. Quantity squared. Can we see that? So the factoring of this trinomial on the left side is what? X plus 1 half quantity squared. Again, the number that goes into the factoring of this perfect square trinomial will always be what? Half of the x coefficient. Keep that in mind. Half of 1, invisible 1 right here, is 1 half. Alright? That's equal to what? 3 plus 1/4 is what? 3 1/4, right? But 3 1/4 as an improper fraction is going to be what? 13 over 4. Again, you can punch out into the calculator if you like, but hopefully we can add 3 1/4 without too much trouble and putting it in what? Putting it in improper fraction format. All right. Now take the square root of both sides. All right. So I get what? X plus 1 half equal to plus or minus what? Now I need to when you take the square root of a fraction, you need to square root the numerator and the what? Denominator separately. So I'm going to get plus or minus square root of 13 on top. Can we see that? 13 there, okay. And then what's the square root of 4 on the bottom? Isn't that 2? Yes, it is. All right. Let's finish it off. Subtract 1 half to both sides. Okay, subtract 1 half to both sides. So I get x equal to negative 1 half plus or minus square root of 13 over what? 2. Can we see that? All right. But also see something else as well. These two fractions have the same what? Same denominator. So couldn't I combine the numerators? Yes, I can. So let me write this as negative 1, right? Minus 1 here, negative 1, plus or minus square root of 13 all over what? 2 as our solution here. Okay, so sorry to squeeze it probably into a tight space there, but hopefully you see all the steps in logical fashion here, alright? So final solution again is x equal to negative 1 plus or minus square root of 13 over 2. Alright, let's try another one here. Let's look at x squared plus 7x. Alright, plus 7x Actually, let me make it minus. Let me go and clear it out. Sorry about that. Let's try this one. X squared minus 7x. Let's make it minus this time, all right? Minus 7x minus 2 is equal to, let's make it equal to 4, for example. All right? Let's go and do that. Okay, then. What do I do first again? Well, I need to move this constant term to the right side. So let me do what first? Add 2 to both sides. So again, before you figure out what number to add to both sides, you need to get rid of the constant term on the left-hand side. So I'm going to have what? I'm going to have x squared minus 7x equal to what? 4 plus 2 is just 6. All right? No big deal there. All right? Again, let's do an aside here. Let's take half. Let's take half of what? What's the x coefficient? Negative what? Negative 7. Half of negative 7 is what? Negative 7 over 2. Can we see that? 1 half times negative 7 over 2. Are we good on that? And then what? Square that number. Negative 7 over 2 squared. That's going to be what? Positive. Negative number squared is positive, right? Positive what? 49. Because 7 squared is 49 over what? What's 2 squared? 4. Can we see that? So this equation becomes what? I'm going to add this number to both sides here. So this equation becomes x squared minus 7x plus 49 over 4. All right, add that to both sides. So that's going to be 6 plus 49 over 4. Again, I'm adding the same number to both sides of the equation there. Make sure we see that. All right, let me go ahead and look at the factoring here on the left-hand side now of this equation. Again, that's guaranteed to be a perfect square once I add this number, right? That's why completing the square works. So then I'm going to have what? X minus, again, what number is half of negative 7? So minus what? Minus 7 over what? Over 2. Can we see that? Again, the number that goes into the factoring is always what? Half of this x coefficient. Always half. Can we see that? Quantity what? Squared. Okay? Equal to 6 plus 49 fourths. Let me punch out the calculator. 6 plus 49 over 4 on the calculator there. So 6 plus 49 over 4 equal to, let me get it as a improper fraction, 73 fourths. Okay, so use the fraction on your calculator. Gives me 73 over 4. All right, we good on that? Now take the what? Square root of both sides then once I have that situation. All right? So once I have a perfect square and a number on the other side, you just take the square root of both sides from the previous homework. So I'm going to get what? X minus 7 halves equal to plus or minus once again. Again, how do I take the square root of a fraction? You square root the numerator and denominator separately. So I'm going to get square root of 73 on top, which I cannot simplify because that's already nothing will come out, that is. That's already a prime number there, for example. All right? Over what? What's the square root of 4? 2. All right? Let's finish it off. Add 7 halves to both sides in this case to get the x by itself. So I get x equal to what? 7 over 2, 7 halves, plus or minus square root of 73 over 2. All right? But again, same denominator, so put them together. So final answer is going to be what? 7 plus or minus radical 73 all over what? 2. Okay, so that's what x is equal to as our solution here. All right, can we see that? So again, not too bad at all. Let's throw in a coefficient for x squared, though. Okay, let's try a new example here. All right, let me go and clear up the screen. In this case, how do we go about handling that situation? All right, so let's look at that one. Let's look at something like this. 3x squared minus 6x minus 2 equal to 0. All right. Now I have a coefficient of x squared other than 1 from all the previous examples we did. All right. How do I handle that in terms of completing the square? Well, first thing we're going to do again is to what? Get the constant term to the other side. Again, I'm going to add 2 in this case. Okay, not too bad. All right. So I get 3x squared minus 6x is equal to 2. All right. Not bad at all. Now, to complete the square, the x squared coefficient must always be 1. So let me make a note of that. So note, all right? Let me say, make the x squared coefficient, make the x squared coefficient a 1. All right? Turn it into a 1. All right? In other words, make this 3 into a 1. How do I do that? Well, I need to divide out the 3 then, because it's 3 being multiplied to x squared. So I need to divide both sides of this equation by 3. That means what? Divide everything by 3. Can we see that? That will get rid of this 3. Now I have x squared minus what? 2x equal to 2/3. All right, so now we're good. All right, so once I have the x squared coefficient be 1, then I'm ready to figure out what number to add to both sides. Again, how do I figure out that number? Well, you take half of the x coefficient, so I'm going to take half of -2 in this case, which is the x coefficient. So half of -2 is what? -1, right? -1 there, okay? And square that -1. So -1 square is what? +1, all right? Can we see that? All right? Again, we take half of the x coefficient, which is -1, and then you square that, you get +1, all right? That's the number we add to both sides. X squared minus 2x plus 1 equal to 2/3 plus 1, all right? Add the +1 to both sides, all right? Now again, that's a perfect square, and what's the factoring? What number goes into the factoring of this perfect square trinomial? Again, the number that goes into the factoring is what? Always half of the x coefficient. Half of -2, -1. All right, quantity squared. All right, are we good on that? Again, number that goes here in the factoring is always half of this number. Keep that in mind. Equal to 2/3 plus 1 is 1 2/3, which is what? 5/3. Is it not? All right. Okay, let's take the square root of both sides. All right, so I get x minus 1 equal to plus or minus the square root of 5 over the square root of 3. Can we see that? All right. So neither the numerator or denominator are perfect squares. Are you with me on that? All right. I probably should have put the plus or minus in the middle of the fraction here, but no big deal. All right. But since the denominator is a radical, remember I need to what? Rationalize the denominator. Notice I need to get rid of this radical here. How do I do that? Remember this problem from 10.3? You need to multiply by radical 3 over radical 3 to get rid of this radical in the denominator. Again, we need to get rid of all radicals in the denominator. That's called rationalizing the denominator, back in section 10.3. Check your notes on that. All right? Okay then. So let's go ahead and figure it out. So that means we basically, let me continue up here then, since I ran out of space. So we basically have x minus 1 again on the left side equal to what? Plus or minus, what is radical 5 times radical 3? Radical 15 all over what? Root 3 times root 3 is just what? 3. All right, can we see that? Let's finish it off by what? Adding 1 to both sides. All right, so x is equal to 1 plus or minus square root of 15 over what? Over 3. All right, are you with me on that? All right, there's my plus 1 here, plus or minus root 15 over 3. All right? Now, you may also wonder, okay, should I combine these two into one fraction? Yeah, you can if you like. So, for example, is 1, what's 1 over 1, right? What's the common denominator? Isn't it 3 then? Isn't 3 the common denominator here? So look at this then as what? So 1 plus or minus root 15 over 3 can be written as 3 over 3, which is 1, right? Plus or minus root 15 over 3. And then now I have the same denominator. Now I can combine the numerators. So I get 3 plus or minus radical 15 on top, all over what? 3 on the bottom. So your book may have the answer in this format instead of this format, but either answer is correct, as you can see right here. Okay? Here it's just a matter of combining these two numbers into one term, into one fraction. Combining these two fractions into one fraction. Think of 1 as 1 over 1 once again. All right. So hopefully we see that. But again, the main idea here is what? Before we complete the square, we must get the x squared coefficient to be what? To be a 1. All right. And how do I do that? Divide out the 3 in this case. Divide both sides by 3. Divide everything by 3. That means. All right. Let's try another one here. Why don't you go and clear out the screen? All right. Let's go and look at this problem here. Let's look at 2x squared. 2x squared, let's make it plus 5x. Plus 5x is equal to 1, for example. All right? So let's go and try that out. Okay, then. Again, let's complete the square on that. So since there's no constant term to move over to the right side, I'm just going to what? Get this coefficient to be what? To be a 1 by dividing everything by 2. Okay, divide everything by 2. Takes care of 2's here. So I get x squared plus 5 halves, 5 over 2x, equal to what? 1 half. Are you with me on that so far? Okay? Now, let's figure out number to add both sides. Again, how do I figure it out? We're going to take half of the x coefficients, or half of what? Half of 5 halves, because isn't 5 over 2 the x coefficient? Yes, it is, right? So what's half of 5 halves? Well, look, 1 times 5 is 5. 2 times 2 Okay, sorry for the interruption there, alright? So 1 times 5 is 5, 2 times 2 is what? 4, alright? So, and then what I do again, I take half of this coefficient, half of the 5 halves, which is 5/4. What do I do with that? I'm going to square that, right? So, again, completing the square, we take half of the x coefficient, and we square it. So what's 5/4 squared? That's what? 25 over what? What's 4 squared? 16. Alright? So I'm actually adding 25/16 to both sides. Can we see that? Hopefully, don't let the fractions throw you off. Just use your calculator, alright? So I'm going to get x squared, alright, x squared plus 5 halves x plus 25 over 16 equal to 1 half plus 25 over 16. Hopefully you can see that without too much trouble there. Okay? Alright then, that's a perfect square now, alright? So let's go and factor it then. Well again, what number goes in here for the factoring of this perfect square trinomial? Again, the number that goes here is always what? Half of this number. What's half of 5 halves? Well, we figured out earlier, half of 5 halves is what? 5/4. 5/4, right? So it's going to be x plus 5/4 quantity squared, alright? Equal to what? 1 half plus 25/16. Let me punch out the calculator here. Just use the fraction to your calculator. 1 half plus 25/16 is equal to, as an improper fraction, 33 over 16. So 33/16 on the calculator. Alright? Let's take the square root of both sides. Alright? So I get x plus 5/4 equal to what? Plus or minus, alright? Plus or minus what? Square root of 33, which I cannot simplify it anymore, over what's the square root of 16? 4. Can we see that? Let's finish it off. Subtract 5/4 to both sides to isolate the x here on the left-hand side here. Alright, that takes care of that, right? So I'm going to get x equal to negative 5/4. Alright, plus or minus, and plus or minus what? Root 33, square root of 33 over 4. Alright, now these two fractions have the same denominator, so just put them together. So final answer is going to be what? Negative 5 plus or minus square root of 33 all over what? 4 as our solution here. Alright, so again, make sure we can handle a quadratic equation when the x squared coefficient is not a 1. We just simply divide it out to make it a 1. Right? So that's not too bad. And then we go through the same routine for getting the number to add to both sides. But we factor it carefully. Again, the key is what? When you factor this, the number that goes into the factoring of the perfect square is always what? Half of this number, half of the x coefficient.
Now let's take a look at another technique for solving quadratic equations called the quadratic formula.
Now the quadratic formula is really based on the completing the square concept. So let me do this. Let me solve the general quadratic equation for you, and then show you how we get at the quadratic formula. All right. So let's go and solve this problem by completing the square. Let's solve ax squared plus bx plus c equal to 0 here. Right, by completing the square. Right, by completing the square. So yeah, what do I do when I do that? Again, a, b, and c are what? Numbers. Okay, keep that in mind. A, b, and c are numbers. X is the variable here. All right, make sure we see that. All right. So first thing we're going to do, excuse me, is to get the constant term on the other side. Let's subtract c on both sides to get it on the other side. So I have ax squared plus bx equal to negative c. Are we good on that? All right. Then I need to make the x squared coefficient a 1. So let's get rid of the a. Let's divide everything by a then to do that. So divide both sides by a. That will cancel these a's out. All right. That will give me x squared, which makes the coefficient 1, which is what I want. Plus, what's the coefficient of x now? B over what? B over a. B over a x equal to negative c over a. Okay. So far so good. Can we see that? All right. So let's see how this turns out. Okay. Now, what happens next? Well, after I do that, I'm going to figure out the number to add to both sides. This is an a here. Sorry about that. Okay. So let's figure out the number to add both sides. How do I figure out what that number is? Well, I take half of the x coefficient. So here's the x coefficient right here. All right. I'm going to take half of that. Half of b over a. All right. That's what? Well, that's just b, 1 times b and 2 times a, right? So that's b over what? 2a. Can we see that? And then after I take half of that coefficient, what do? I square it. So b over 2a squared. I'm going to square that. All right? So what I get? Well, I get b squared on top. Can we see that? Over, what's 2a squared? Isn't that 4a squared on the bottom? Hopefully we can see that without too much trouble, all right? So this is the number I'm going to add to both sides of this equation. So this equation becomes what? Becomes x squared plus b over ax plus this number right here, b squared over 4a squared, whatever this number is, equal to negative c over a. Again, I must add the same number to both sides, right? So plus b squared over 4a squared. All right, can we see that? All right, then. Again, once I do that, the left-hand side is guaranteed to be a perfect square. And what is the factoring then on that? Well, just like the last section, I'm going to have x, and the number that goes here in the factoring is always what? Half of this number. What's half of b over a again? Well, didn't we figure it out earlier? Half of b over a is what? B over what? 2a, right? So it's going to be x plus b over 2a quantity squared. Can we see that for the left-hand side? And that's equal to, all right, let's look at the right-hand side. So negative c over a plus b squared over 4a squared. Let's get the common denominator, right? Because what is that going to be? A and 4a squared. Isn't the LCD here 4a squared? Yes, it is. All right. So to make that happen, I need to multiply. Let me go and write this fraction first. So this fraction already has the LCD, so it stays the same. So let me write this as, in fact, let me work on the side here. So b squared over 4a squared minus c over a, essentially down here, right? So, and we mentioned the LCD is 4a squared. So therefore, let's multiply by what? 4a over 4a to the c over a to get the 4a squared on the bottom here, right? So that'll give me what? That'll give me b squared minus what? Now, c times 4a is what? 4ac, sorry to write close to the edge here, all over what? Again, LCD is what? 4a squared. Can we see that? All right? So, in other words, what I get on the right-hand side of this equation down here is going to be what? B squared minus 4ac over 4a squared. So I get b squared minus 4ac all over 4a squared. Are you with me on that? All right? Now, let's take the square root of both sides. Again, x is the variable. A, b, and c are numbers. All right? So x is what I'm solving for here. So I need to take the square root of both sides here to make that happen. Can we see that? All right? So I'm going to have x plus b over 2a on the left side equal to plus or minus, again, plus or minus, you get when you take the square root of both sides, right? All right? And square root of numerator, so square root of b squared minus 4ac all over what? The square root of the denominator. What's the square root of 4a squared? Isn't that 2a? Yes, it is, right? Root 4 is 2. Root a squared is a. All right, are you with me on that? All right, let's go and subtract b over 2a to both sides then. Minus b over 2a to both sides of the equation. So this is very complicated, so bear with me here. All right, so I get what? I get x equal to what? I get negative b over 2a, negative b over 2a, plus or minus this quantity right here. Square root of b squared minus 4ac all over what? 2a. All right, can we see that? Negative b over 2a plus or minus this guy right here. Okay, again, same denominator, just put it together. So x is equal to what? Negative b plus or minus the square root of b squared minus 4ac all over what? 2a. So my solution after I complete the square on the standard quadratic equation up here is going to be x equal to negative b plus or minus the square root of b squared minus 4ac all over what? 2a. So this is what I come up with. All right, that's my solution. All right, and this, my friends, is called the quadratic formula. Okay, so this is the quadratic formula. Let me write it again neater on the next screen here. Okay, so again, you see all the algebra involved in completing the square of this standard quadratic equation. But that's where the quadratic formula comes from. It comes from completing the square. Can we see that? All right. Again, let me clear the screen. I'll write again. Okay. Okay. So again, for the standard quadratic equation, ax squared plus bx plus c equal to 0. The solution is x equal to negative b plus or minus. Sorry about that. Let me try again. Ax squared plus bx plus c equal to 0. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, this is the quadratic formula right here. Okay, quadratic formula. All right, and that's what we'll use to solve problems in this section here in 11.3. Right? So to use the quadratic formula, observe a couple of things. First, I need to figure out a, b, and c. All right, figure out what those numbers are, and we'll do some examples in a moment here. All right, and second of all, I need to get it in this form. In other words, I need to get this standard form here: ax squared plus bx plus c equal to 0. All right, so let's try a problem like that. All right, let's look at a problem like this. All right. So consider this problem. Let's look at the problem. Let's make it 2x squared minus 2x minus 1 equal to, let's make it equal to 4, let's say. All right? Okay? Let's see how this turns out. Okay then, I want to solve by quadratic formula now. Again, let's ask ourselves, is this quadratic equation in this standard form? Well, the answer hopefully is no, right? Can we see that? Because why is it not? Because the right-hand side is not what? It's not 0. So again, you must get one side to be 0 before you apply the quadratic formula, in other words, right? So let's subtract 4 on both sides to get it in this format right here, okay? So it's going to be 2x squared minus 2x minus 5, negative 1 minus, that's a 4 there, sorry about that, equal to 0. All right, you with me on that? All right, now, is this in the form I want then? Yes, it is, because I have 0 here on the right-hand side, and I have my a, b, and c, so let's identify that. A is equal to what? 2, all right, positive 2. B is equal to what? Negative 2, because b is the coefficient for x, that's negative 2 here. And what's c equal to? Well, that's the constant term, negative 5. Can we see that? Are you with me on that? All right. So again, clearly be able to identify A, B, and C as such. All right. Now, what do I do next? Well, just plug it into the formula. So therefore, let me continue up here since I ran out of space. So therefore, I'm going to get x equal to negative b, right? So negative b. What's b? B is negative 2. So negative 2 plus or minus the square root of, make a big square root there. All right. Square root of what? B squared. So what's b again? Negative 2. So negative 2 squared. B squared minus 4 times, I'm running out of space here, times a times 2, which is a here, and then times c, which is negative 5. So let me squeeze in times negative 5 down here. So I ran out of space there. I couldn't fit it in here. All right. all over what? 2 times a, right? 2 times a. So a again is 2. So 2 times 2. All right, can we see that? Once again, let's repeat it. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Can we see that for the quadratic formula? So memorize this formula. Write down the formula for every problem you do, in fact. That's what I recommend to help you remember this quadratic formula. All right? I like it more than completing the square because all you do is plug numbers in and then work it out. But you work it out very carefully. It's easy to make a mistake when you work it out. For example, what is the opposite of negative 2? That's positive 2 plus or minus the square root of, what is negative 2 squared? That's positive 4, all right? And look at this here. What is negative 4 times 2 times negative 5? So negative 4 times 2 is negative 8 times negative 5 is positive what? So negative 8, positive 40. Can we see that? All right? All over what? 2 times 2? 4. Are you with me on that? Once again, opposite of negative 2, positive 2. Negative 2 squared, positive 4. Negative 4 times negative 2 times negative 5, positive 40. Are you with me on that? All over 2 times 2, 4. Okay, make sure we clearly see the arithmetic there. All right? So let's work it out. So that's 2 plus or minus the square root. What's 4 plus 40? Isn't that 44? Yeah, it is. All over what? 4. All right? And let's simplify root 44. Couldn't you do that? Because isn't that 4 times 11, right? Couldn't I take out a what? Couldn't I take out a 2 here? That's a 2 right there. Sorry about that. All right? So isn't this, again, I'm just simplifying, right? Isn't that 2 plus or minus 2 radical, what's left? 11 inside. All right? All over what? 4. All right? So maybe it's not so easy after all, as you can see, right? But again, it just comes down to you being able to plug numbers into this formula and simplify the arithmetic here. All right. Now, can I reduce this? Yeah, I can. Because look, 2, 2, and 4, they're all even numbers. I can cancel it, right? Now, here's how I cancel that, though. I'm going to factor out a 2, because these two terms have 2 in common, right? Let's take a 2 out. So what's left? 2 times what is 2? 2 times 1 plus or minus 2 times what will be 2 radical 11? Just radical 11. Can we see the factoring here? If I take a 2 out, 2 times 1 is 2. 2 times radical 11, 2 radical 11. All over 4. All right? And then 2 can cancel with 4 down here to give me 2. All right? So my final answer for this quadratic equation here is going to be x equal to what? 1 plus or minus square root of 11 all over what? 2. Okay, so there's your solution here. Alright, so applying the quadratic formula. Let's try a couple more and then we'll give you some problems to post on Blackboard. So all this is just using this formula here, right? But again, before we can use that formula, we have to get the equation in this format right here, okay? Which means one side has to be 0, alright? And then we figure out A, B, and C at that point. And then we just plug into the formula. Alright, let's try another one. Let me try out the screen. Alright, let's try this one. Let's look at x squared plus 8x is equal to 8, let's say. All right. Well, again, is this in the standard form we want? Is this in the form of 8x squared plus bx plus c equal to 0? Because that's the form I need before I can apply the quadratic formula. And the answer is no, it's not. I need to move this 8 over to the left side. Let's subtract it out. Hopefully you see that without too much trouble. So we get x squared plus 8x, all right, minus 8. Again, these aren't like terms. You can't combine them, right? Equal to 0. Okay, now I'm ready to identify A, B, and C. A is equal to 1. B is equal to 8. C is equal to negative 8. Hopefully we can see that without too much trouble here, all right? Again, what's the quadratic formula? Write it down. So, in fact, let me write it up here if you don't mind. X is what? Negative b plus or minus the square root of b squared minus 4ac all over what? 2a. All right, so again, write down the quadratic formula. So that's what I'm going to plug into here, okay? So, again, x is going to be what? Negative b. So b is 8, right? So negative 8 plus or minus square root of b squared, so 8 squared, okay? You can use parentheses if you like. Oops, sorry about that. Minus, sorry about this mark here, minus what? 4ac, so minus 4 times what? Times 1 times c, negative 8, all right? All over 2a, 2 times 1, right? A is 1, right? No big deal. So that's going to be negative 8 plus or minus the square root of what's 8 squared? 64. Again, sorry for this mark here. Negative 4 times 1 times negative 8. Isn't that positive what? 32, all right? All over 2 times 1 is 2, all right? Simplify this carefully. So that's going to be negative 8 plus or minus the square root of 64 plus 32 is what? 96, all right? All over what? 2 on the bottom here, all right? Now, let's look at 96. Isn't that 16 times 6 here, all right? Again, just think about that carefully and use your calculator to help you simplify that, right? Again, try to find the highest perfect square. That's a factor of 96. You see 16 times 6 out here. Hopefully. It's not too bad. All right? So what comes out from the 16? Well, 16, I can take out a what? I can take out a 4, couldn't I? All right? So let me continue up here then. So my final answer is going to be, well, no, not quite my final answer, but my next step, that is, I should say, is going to be negative 8 plus or minus what? 4 on the outside, square root of what? 6 on the inside. All right, all over what? 2. All right, and can I simplify 8, 2, and 4? Yes, I can. Right? I can take out for example, here I can factor out 2 here. Yes, I can take out a 4, but I'm not going to do that. I just want the 2 to cancel out, right? So you just cancel directly. It's up to you. I'll show you that in a moment. So let me take out 2 here instead, all right? So I'm going to have negative 4 because that's negative 8, right? Plus or minus 2 radical 6. All right, 2 times 2 is 4 here. Okay, so 2's drop off. So my final answer is going to be negative 4 plus or minus 2 radical 6. 6 right there. Okay, so this is the solution we're looking for. All right. Negative 4 plus or minus 2 root 6. Now let me go back to this problem right here. So suppose in terms of simplifying this fraction right here, all right? So I have negative 8 plus or minus 4 radical 6 all over 2, all right? Let's observe that both of these numbers, 8 and 4, are divisible by 2. So therefore, divide all three of these numbers by 2, all right? All these three numbers are divisible by 2. So 2 into 8 how many times? 4 times. 2 into 4 twice. 2 into 2 once, all right? So you still get the same thing, negative 4 plus or minus what? 2 root 6. Okay, so same answer as here, all right? Of course, over 1, but I leave that off. Okay, so there's my solution, same thing. Okay, so just a tip on simplifying these fractions here. All right, let's do one more. So again, quadratic formula, all we do is what? Just plug into the formula here, right? not really a big deal here. Let's just try this one here. All right, let's look at x squared equal to 3x plus 5. All right. Again, get it in the standard form, okay, which is this form here, ax squared plus bx plus c equal to 0. So don't identify a, b, and c yet. Get it in this form. Get the equation in this form before you identify a, b, and c. That means what? Since the x squared term is positive on the left-hand side, let me move the 3x and the 5 over to the left side. Minus 3x minus 5. Minus 3x minus 5 to make that happen. So we see that do the same thing to both sides, right? 3x's drop off. 5's drop off. So I have 0 here on the right side. I have x squared minus 3x minus 5. Now I have it in the standard form. All right. So a is what? 1 again. B is what? Negative 3. C is what? Negative 5. Hopefully we can see a, b, and c pretty clearly in this equation. All right. Once again, let's plug into the quadratic formula. So x is equal to what? Negative b. Again, I'll write it out again. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, you want to write the formula down for each problem. Okay? So I get negative b, so negative 3. So that opposite of negative 3 there. All right, opposite of b. All right, plus or minus big square root here. B squared, so negative 3 squared, all right, again, b squared, all right, minus 4ac, so minus 4 times 1 for a, c is negative 5 times negative 5, all right, all over 2 times 1 again, 2a, all right, which is 1. All right, are you with me on that? So that's going to be opposite of negative 3 is what? Positive 3 plus or minus the square root of, all right, negative 3 squared is what? Positive 9. Just do the math carefully here. What's negative 4 times 1 times negative 5? Isn't that positive 20? Yes, it is. Positive 20 all over 2. 2 times 1. Which is going to be 3 plus or minus the square root of 29 all over 2. Right? 9 plus 20. And can I simplify that? No, I cannot. So this is the final solution we're looking for. Okay? So x is equal to 3 plus or minus radical 29 over 2. All right. Again, make sure we just plug it in carefully in terms of the numbers here. Okay? All right, so make sure we get it in standard form first before we start identifying A, B, and C also. All right. Let me give you some prompts to post the answers to using the quadratic formula into the discussion area in Blackboard. Okay? I'm going to go and clear out the screen. All right, let's go ahead and try some of these prompts here and then post them into Blackboard. All right, let's go ahead and try this one here. Let's look at x squared minus 4x is equal to 1. Try that one. All right. Use the quadratic formula. Again, you can use actually on the exam you can use either quadratic formula or what the quadratic or the completing the square technique. Again, but try to use the one that works best for you. Okay. So, but since this section we're practicing quadratic formula, let's go and use quadratic formula to solve it. All right. Okay. Next question is going to be what? Y squared minus y minus 3 equal to 0. Okay, try that one. This one is already in that standard form. Notice that. That's pretty good. You can identify A, B, and C right away and start plugging in the formula. All right. And finally, let's look at 2x squared plus x minus 7. All right, is equal to 0. Okay, again, also in the standard form already here. So you see you could see you can work that out. Again, post the solutions to these 3 questions in the discussion area in Blackboard. Again, how do I post plus or minus once again? Okay, so if I have my answer, let's say my answer is x equal to to say 1 plus or minus square root of 5 over 2. Let's say you got this answer, solving it on paper, right? How do you post this? Post this as 2 answers in Blackboard. Post this. here's how you would type that in. You would type in. There's actually a math feature in Blackboard, but it's not that easy to use. So you might want to just type it in this way. So break this up into 2 answers, right? Plus and what? And minus, right? So it's going to be 1 plus, and use parentheses. 1 plus SQR 5 again. Square root for SQR, right? Because we don't have the square root button unless you use the math feature in Blackboard, all right? And then close parentheses again, slash what? Divided by what? Divided by 2. And then your other answer is going to be 1, put in parentheses, 1 minus SQR. SQR means square root, right? 5 again. Sorry about that. 5. It's a 5 there. Sorry about that. And then close parentheses, slash. That means divide, right, and then by 2. Again, so what I'm saying is what? Break it up when you post the answers to Blackboard. Break it up into 2 answers here, all right? And also use SQR for square root, since there's no square root feature in Blackboard unless you use their math feature, which can be complicated to use. So it's up to you, but again, make sure I clearly understand what answers you are posting there. Okay? So again, try these 3 problems out. Post the solutions to the discussion area in Blackboard, and we'll go over the problems in class. All right, until next time.